starting the recording. So, happy Tuesday and garbage day to those of you in the Coralville area. Made sure to take my garbage cans inside right away so they wouldn't blow all over the neighborhood. It's going to be one of those kind of days. So this morning I downloaded your homework 3 revisions, and a couple of you messaged me about being late. No, I screwed up the due date and icon. It wasn't due Sunday. I just clicked the wrong button. It was due last night as usual, so no one submitted anything late. And if you submit it 1 minute late, I can live with that. I'm returning them to you as I process them. I should be able to get most of them done by tomorrow morning. And homework 5 then is the next thing on your agenda for next Monday. So are there any questions on expectations for that or what you're supposed to do? Hopefully you've downloaded the instructions at least. If nothing else, that's usually a good place to start. No? No. Yes? No. Okay, well, then fine. Good with that. Let's see. I think that's all the update stuff. We have the rest of the invariance unit to work through today for sure, and probably part of Thursday as well. So I have in front of me the longitudinal example that we started last time. So I can review the steps that we took to get through the measurement invariance portion of it, because there were a considerable amount of steps in this example. So just to recall, these are real data from a former student. These are 6 different subscales being treated as indicators for pragmatic reasons, because this is a relatively small sample, that were administered at 6-month intervals to patients in a psychiatric rehabilitation center. So we're looking at their change across occasions in the behaviors that are being measured by these scales. So the first step was configural invariance, which looks different in longitudinal types of models, or when you have a dependent sample. All the factors have to be in the same model. So it's not a multiple group model. It's just being treated as a separate factor for each occasion. So I named them time 1, 2, and 3. And at the configural stage, we don't have any constraints other than the ones needed for identification. So we have all the loadings, all the intercepts, all of the residual variances, error variances, excuse me. Each factor has its variance fixed to 1 and its mean fixed to 0 for identification. So these factors are not on the same scale at this point. And then the rest of it is the part that's unique to dependent samples. We would have factor covariances. So this line width, where you list a series of things and then the same series, what that does is give you all possible pairs. That way you don't have to list them all out. And I did the same thing here for the error covariances of the same indicator across time. Those get to be estimated by default without any constraints, because we expect what people said to an item at one occasion to be related to what they're going to say at another occasion. So whether it's an item or a subscale, that would be the case. And we looked at the fit, and it was not great, but we couldn't do anything better to make it fit better without compromising the integrity of the model, so I told the student, just go ahead and make it work. So first step then, metric invariance, otherwise known as, we'll play the synonym game again. Synonym for metric invariance. Weak, yes, and it constrains, it pertains, both of those words were in my head at the same time, to the loadings. So this is the big one. It's really the definition of the factor is called into question if the loadings are not the same across occasions. So we constrain all 6 loadings to be the same across occasions. Still fixing my typo, there we go. And at this stage, we also have to free the factor variances at the non-reference occasions. So I'm treating time 1 as the reference in terms of how the model is identified. Its factor variance is still fixed to 1. By constraining the loadings across to the items at other occasions, we are able to then free the factor variances at the subsequent occasions. So we can ask the question, is the reasons why the loadings want it to differ because the factor variance differs? And according to my likelihood ratio test against the configural model, yep, significantly worse. So keep in mind, these are all constraints. When you take parameters away, you can make the model worse or not worse in terms of absolute fit via -2 log likelihood. And we used the modification indices to try to figure out why it was significantly worse. And the largest one pertains to the the loading of item 1 at time 1 on the factor for time 1, meaning that loading wants to be different. So we let it be different by giving it a separate name, loading 1A at the first occasion. Repeat the likelihood ratio test, and it is not worse, so we win. So item 1 is more related to the factor at the first occasion, is the conclusion we would come to based on the unstandardized loadings. Scalar invariance was then the next item up for bids. We kicked out item 1 at time 1 because it had already failed metric, so single elimination tournament kind of idea. Constrained the rest of the intercepts to be equal to each other over time, and then freed the factor means at the alternative occasions. So this is the idea that the reason why the item means may have differed over time, we're seeing if it's because of the factor means or because of some other stuff in addition. And this fit significantly worse, so we went through a long process of trying to figure out which specific intercepts were the problem. So freeing them one at a time, tracking the change in fit, continuing until it fits not worse than the previous model. Then we did error variances, and at this stage there's no special, actually there is a special name, I take that back. So I skipped over one. We had metric is weak, right? What's scalar?
Strong.
Strong, yeah. What is error variance and variance? One more word. Strict, yes, the Zoomers had it. And at this stage, we don't have to free anything with respect to the structural model. This is just, we let the error variances be the same or not, is the question. And in this case, it took a few rounds of getting them to be troubleshot. Is that, can I say that? Past tense of troubleshoot? Troubleshooted? I don't know, troubleshot sounds weird to me, but we'll go with it. So lots of troubleshooting, for sure. And we finally got to the end result, and we were ready for structural invariance. And so several items had different factor variance. For instance, less variance at time 1 for the first indicator, more variance at time 1 for the second indicator, more variance at time 1 for the fourth indicator, and less for the fifth. So item 5 wanted to be different all the way across the board, so whatever reason. Okay, so a review of where we were last time, and then I think we left off at structural invariance. So any questions on that? Process or logic? Zoomers, we good so far? There's no faces today, so I'm just looking at your black boxes. There's one. Hi. You don't have to have your camera on if you don't want to. I'm not trying to shame anyone. Just the lack of feedback is a little bit disconcerting. So, any of you teach hybrid format? Any of you else get to do this? No?
I did my first year during coronavirus in grad school. So, yeah, when you're just staring at a bunch of black boxes and nobody's responding, it's weird.
It is. Yeah, it's even weirder when I record lectures in my basement and there's literally no one there, right? Like at least everyone here is theoretically in front of me. That's a weird thing to lecture into outer space, but I digress. So structural invariance in this context is answering a different question than you would think. So the point of this entire analysis is that this student wanted to examine growth in a latent factor over time. And in order to be able to do that in a meaningful fashion, we have to demonstrate that the factor is conceptually the same thing over time. So this factor is just, it's being held together over time, but there's a lot of holes in terms of things we had to free along the way. So we're able to do this, but with those caveats in mind. So structural invariance tests then concern the factor variances, the factor covariances, and the factor means. So from this point, we have the factor variances fixed back to 1, so that puts a constraint to make them all equal to each other again. The model is still fitting mediocrely, if that's a word, but it didn't fit worse than the previous residual variance invariance model, so it looks like the factor variances can be roughly the same. If I go to what the solution was before to see how they turned out, here's what they were estimated as. So the first one is fixed to 1 for identification, the second one was estimated as 1.1, and the third one was estimated at 0.9. So the fact that I can fix all of these to 1 and have the model fit not worse means that there's essentially the same amount of variance at each occasion. 1-ish it's happy enough with. The factor covariances were these three numbers in terms of how related the factors are over time. So how successful you are on these measures at time 1 is positively correlated with how you'll do at time 2 and 3, as one might expect. We did the same test of trying to make sure that, see if they could all be constrained. And I did it this way. So I don't think you've seen something that looks like this yet. There we go. So this is the line right here that requests the 3 covariances. And I put one label at the end of it, fcov. So what that is doing is naming and constraining all the factor covariances to be the same. So asking whether 0.77 or 0.78, 0.71, and 0.66 can be the same. And survey says, sure, why not? So now they're all estimated at a common 0.7. Here are the factor means. That would be the last possibility. And time 1 has its factor mean fixed to 0 for identification. So the other factor means are relative to that. So it looks like there is indeed some growth over time in this trait. The whole trait is in the scale of time 1 being standardized. So you can think of this as like 0.3 standard deviations of an increase on average at time 2, and then 0.52 relative to time 1 here. So the last thing that we would want to know is whether we could constrain all of these equal to 0 or some of these equal to 0, right? There's 2 possibilities. So I tried that by constraining the last 2 to be the same. So note time 1 still has its factor mean fixed to 0. There's a semicolon that separates that statement so that the label f mean only applies to the last 2. And they did fit significantly worse, so those constraints did not hold. So here's the end result of our measurement model parameters for the intercepts and for the residual variances. And here's the final solution. Now I want to do a crossover event. Several of you have been through multi-level modeling or longitudinal with me, right? Like, I think all of y'all have. Yes? The 3 in the room? Several Zoomers? Okay. So we have just learned that with respect to our latent factors, they have the same variance over time, and they have the same covariance over time, but they have mean growth. So if you have a model for longitudinal data in which the variances are the same across time and the covariances are the same across time, do you know a 2-word phrase that would describe that pattern? You remember it? Nod? What is it called in terms of a pattern of residual variance and covariance when all the variances are the same and the covariances are the same? Anybody? No? Vladimir, what's it called?
Yeah, I want to talk.
Yeah, I'm calling on the TA.
It is compound symmetry, right?
Compound symmetry is what it's called. So in terms of how you would describe change over time, if compound symmetry holds, what does that mean about change across people? It means that they change the same. The only way that the variance can stay the same over time is if your growth curves are parallel. So is that good news or bad news for this student, do you think? Could be good, could be bad. It depends on your goal. This student wanted to predict individual differences in change over time. There are no individual differences in change over time. Game over. So this is an example of structural invariance holding being bad news, because if people grow differently, they spread themselves out over time. That makes the variances change over time. It makes the covariances change over time. So it looks like everyone is improving to some extent. They improve the same. And at this point, I told the student, like, you're not going to find anything. It's like, well, can I still try? Go right ahead. I'm sorry, I'm right. You know, it's not going to work. So, individual differences in change, not part of the story for this. But here's the write-up for all of these things. But don't feel too bad, the student did graduate, because getting a significant result is not required to graduate. You just need to do what you set out to do that your committee agreed to. All right. Any questions on that example? None from the Zoomers? Any from the Roomers? Okay. By the way, Longitudinal is coming back in the fall, and I plan to offer the advanced version of it as a follow-up next spring. So if you're interested, you can ask me more about that if you'd like.